Okay, welcome back everyone. Let us start with classification of first let me quickly recall in the last class what are the things we had done. We started with the overview of cryptography. What is the meaning of cryptography, cryptos and graphio, and then what is the crypto system consist of? It is having 5 tuple pcked. P is the set of plain text, C is the set of ciphertext, K is the set of possible keys. And what happens, suppose I am having a key, there will be an encryption rule and a decryption rule, such that suppose I am having a plain text. If I encrypt it, I'll get a new message, new text, that is we call it as ciphertext. So this is Y. And then if you decrypt this encrypted message ek of x, you'll get your plain text. Okay, and what are the goals of cryptography? In short, we said that pain, that is privacy, authentication, integrity, and non-repudiation. One more thing is access control, but that is not widely used. So we'll start with privacy. What do you mean by privacy? Your message should not be revealed to any other guy. It is what this can be achieved by your encryption scheme. And authentication means what? You should able to authenticate the source of the message or the entity who have sent the message. In that can be achieved with digital signature. And has integrity means what? Your message should not be altered or modified. That can be achieved by hash function. Non-repudiations, your actual participants uh, should not able to deny their involvement, so that can again be solved by digital signature, or in advance if you come undeniable signature, that can be done. Okay, next is access control. So access control, that means only legitimate users are granted the access of, that means any third party should not able to get the access of the resources, something like that. Okay, now let us see the classifications of crypto system. Okay, so for a classified study, the crypto system can be categorized in the following classes. So the first class is classical versus modern. Classical versus modern. So what do you mean by that? Classical versus modern. See, this classification is in view of pre and post computer era. Pre-computer era, when the computers were not invented or not in use. This is post computer era. So the crypto system which are designed pre computer era, that is called classical crypto system. The crypto system which are designed post computer era, that is called modern crypto systems. See, broadly they can be analyzed on the basis of time period. Those belonging to early 20th century, or those belonging to late 20th century. So this is early 20th, 20th century, and this is late 20th century. So various example of classical crypto system, if we see, they are Caesar cipher, Wigner cipher, affine cipher, Hill cipher. We'll be seeing all of them mostly, Autokey cipher, etc. And here if you see some examples are your DES, AES, and RSA, algorithm, etc. Okay, so the first classification of crypto system is this. You can, the second one is, I'll change the color. Yeah, symmetric crypto system, symmetric or asymmetric. Another name for this is secret key crypto system. This is also called as secret key crypto system. People call it as SKC, and this is called as public key crypto system. That is called PKC. Okay. So this classification is on the basis of your encryption and decryption key, which we had talked. Based on the basis of encryption key, which is EK, and decryption key. See, the key required to encrypt a message, that is called encryption key. The key required to decrypt the message, that is called decryption key. Okay. So in the case of symmetric key system, symmetric crypto system, your encryption key and decryption key are same. The same key will be used for encrypting and decrypting, whereas in the case of public key crypto system, both are different. There will be a different key for encryption and there will be a different key for the decryption, whereas in the case of symmetric key, it will be same. So if you talk about some examples of symmetric key crypto systems, so all classical crypto systems are on symmetric key. All classical crypto system or block cipher, stream cipher, etc. Stream cipher, etc. And what are the public key crypto system? You can say RSA, algorithm, knapsack, Rabin, NTRU, and etc. Yeah. Okay, so this is based on your encryption and decryption keys. If they are same, then that is called symmetric or secret key crypto system. If they are different, then it is called public key crypto system. So that means there is only one key involved in the case of symmetric key crypto system, and there are two keys are involved in the case of public key crypto system. Okay. Now the third class of the classification is block cipher and stream cipher. Block cipher is stream cipher. Yeah. So this classification is on the basis of encryption process. That means what happens in the block cipher? See, in block cipher, the message is encrypted after being divided into fixed size of blocks. The message is being encrypted after being divided into fixed size of blocks. That means suppose I'm having hello, I am king. So this will be divided. Suppose four people I am dividing it. Hello, and I am king. So block of four words I am dividing it. Forget about if I'm skipping the space. And this is called block cipher. I'm encrypting this, then I'm encrypting this, then I'm encrypting something like that. I'm dividing it into the block of the same size. Correct? So I can encrypt anything. I can encrypt everything together here. Correct? It is not. They are not dependent to each other. Hmm. Whereas, in stream cipher, the entire message is encrypted at a time. The entire message is encrypted at a time using a key stream. Using a key stream. So here it has been divided into block, then it is encrypted. Here all the message will be encrypted at the same time with a key stream. Okay. So you can say it is again a block cipher only, but having only one block. It has only one block. So if you talk about some examples, in the case of block cipher, your DES, AES, and serpent, blowfish, toefish. These are the example of your block cipher. If you say idea, etc. And if you take the example of a stream cipher, so Chacha, seal, snow, LFSR, etc. are some popular stream ciphers. So if you are dividing on the basis of encryption process, these are the two type of thing: block cipher, stream cipher. Okay, the fourth one is deterministic versus randomized. What do you mean by that? It is very simple. The classification is based on nature of encryption process. Based on nature of encryption process. What do you mean by that? If the encryption formula always outputs the same ciphertext. Okay. So if the encryption, I'll put a bracket here. If the encryption rule or formula always outputs the same ciphertext for a fixed plain text, then the crypto system is called deterministic. Then it is called deterministic. That means suppose I'm having message M, I am encrypting it, I'll get this encrypted form, correct? And again I am putting the message M, the same encryption, and I'll get the same ciphertext. Correct? All the time I am putting my message, I'll get the same ciphertext. Whereas in the case of randomized, first time I am encrypting, I'll be getting something like this. Second time I am encrypting, then I may get something like this, and third time I'm encrypting, I may get something like this. That means they are encrypted in different form. I may get something like this. I am encrypting both with the same thing, but I am getting different encryption, different ciphertext. So that is called randomized, where some random numbers are involved in this case. So I'll write here what happens. Output of encryption algorithm, encryption rule depends on some random number. Okay, that is if the encryption of same message yields different ciphertext every time depending on some random number used in the encryption formula, then it is called randomized crypto system. So randomized crypto system are assumed to be more secure than deterministic crypto system. Okay. So if you talk about some examples, again here DES, AES, and RSA, Rabin, etc. These are your deterministic. And if you talk about randomized, then Algamal, Goldwasser, Mikali, NTRU, and so on, etc. These are some example of your randomized crypto system. Next, fifth way of doing it as pre-quantum versus post-quantum. What do you mean by this? See, this classification is on the basis of strength of your crypto system against quantum computer. On basis of strength against quantum computer. What do you mean by that? That means the crypto system which is secure against quantum computer is called post quantum. So here crypto system which is secure against quantum computer. Or quantum algorithm is called post quantum crypto system. Whereas if it is not secure, crypto system which is insecure against quantum computer is called pre-quantum quantum crypto system. So example, if you see that this RSA, Algamal, Rabin, see all the crypto system which are based on you say factorization problem or DLP problem, and then they are pre-quantum because uh, in the quantum era, in the quantum computer era, the factoring problem can be solved and DLP problem can be solved. So uh, these are not your more secure. Whereas if you take the example of post-quantum crypto system, there are so many lattice-based crypto system. Lattice-based, that is, you can say LWE, RLWE, NTRU, lattice-based, hash-based, multivariate cryptography, and isogeny-based cryptography. No, so many examples are there. Okay, so if your crypto system is secure under the quantum computer era, quantum computer, then it is called post quantum, otherwise it is called pre quantum crypto system. Yes. So practically now let us see what is practically use. Maybe yeah, I'll stop in the next class. We'll continue. Thank you so much.